so previously we were talking about the Maya CMDS bounding box method that gives us a bounding box that's oriented in world space. So it's a little tricky. If your object is oriented with the axes, it might look like the box fits it nicely. If you were to rotate your object, you'd see a bounding box like red shown here. It's going to stay locked with the coordinate system shown in green. The coordinate system shown in green is your Maya axes, your XYZ axes for the world. And what happens is, as you rotate your object, that box is going to change in size. It's not allowed to rotate for that type generated from this method. Okay, so you're going to end up with a box like this, and you can see that the width has changed. It's gotten wider there. Okay, so how do we overcome this? We want to get the bounding box that fits the object nice and tight, and that would be this bounding box. The problem is when we rotate our object in the scene, the bounding box is rescaling when we're using that CMDS method. So we're going to change over to the MFN function set and use the bounding box method from the MFnMesh function set. And this is going to be a Maya API method, not a Maya command. Okay, so the next one we're going to look at. So OOBOS, so object-oriented bounding box or object-aligned bounding box. It's going to get the bounding box in the object-oriented bounding box style or object-aligned or oriented bounding box. It's the bounding box max and min in the object-oriented space. So this means if you rotate your object, your bounding box dimensions will not change. The bounding box is changing its orientation to follow the transform of your object. Okay, so the coordinates are relative to the transform of the object. So we have a method, getObject space bounding box. Its input argument is the object name. So again, we're going to use a little different here. It's om.MSelectionList, which is a Maya API method, and this is going to create a Maya om.MSelectionList object. It's a Maya API object. The handle or name for it becomes this variable cell_list. So then we access methods of that API object like this by putting the name and then .add. So the .add is going to add the object name to the selection list object. Okay, it's not quite the same as putting it in an array. It's a little more complicated than that. It's an object that has programming and it does things and it has methods built in, but you can pass in something for it to store inside of its list, inside of its object. Okay, so then DagPath is equal to cell list.getDagPath 0. So this is getting the DagPath root or the transform from the selection list object and then storing it in this variable DagPath. So now you have taken the name out of the thing that's stored in there and passed it into this variable. Alright, so then om.MFnMesh. Okay, MFnMesh has got a bunch of methods to run on geometry meshes, and we want to create an om.MFnMesh object passing in or registering our object name to it, so that it's going to be centered around this object, but it's going to give us all these methods available to this Maya API object. Okay, so MFnMesh becomes the handle or way to refer to this Maya API object, which is focused on this piece of geometry by this name. So then bounding box, now here's where it diverges. We're going to use fnmesh.boundingbox. So .boundingbox is a method of MFnMesh function set. So then from there we have the bounding box getting stored under this variable fnmesh.boundingbox. Okay? So the difference here is this is a Maya API method, and by default it is designed to be aligned with the object's transform, not the axes of the software's space. Okay, so that's the major difference and why when you rotate your object it's not going to change bounding box shape now. Okay, so then we're going to use bboxmin and bboxmax to get the min and max points. Okay, so at this point this is using these methods .min, .max on bbox to get the mins and maxes, store them in min point and max point. So width is equal to the difference between max point.x and minPoint.x. So the dot min is getting the minimum points for x, y, and z and storing them as a triple in minPoint. This is not exactly it's still an object at this point, it's still an API object. It's not a Python list, and you're accessing the .x attribute by doing maxPoint.x. So that at that point is going to turn into a single value. So up here when you got minPoint, maxPoint, these are triples, and when you get down here and you do maxPoint.x, you're accessing just the x of that triple, and then you're accessing just the x of this triple. Okay, so you got min is a triple of mins, x, y, z. Max is a triple of maxes for x, y, z. Okay, so the calculation of the dimensions is done there. Height, width, depth. Okay, and at that point, we're going to print object space bounding box. We're going to print the min, max, and the dimensions. So here, width, height, and depth, at that point, after that difference has been calculated, those are just single values. So they're probably just going to be floats there, meaning that they have an integer value and a decimal place. So again, f-string substitution used to substitute in the variables, everything in the curly braces. It will grab the values stored in those variables, convert them into strings. The curly braces will disappear. You'll get a whole string sentence like this that will print out as one string of text. Okay, and again we're going to use this kind of syntax. So we got selection equals cmds.ls selection equal true. So if something is selected and you run it, it's going to get stored in selection. We got a little bit of logic here, a little different from the last one. If selection is true, then the indented block runs. If there's nothing stored there, then this won't run. It'll just print object not selected. Okay, so it's going to run it. Selection 0 is going to get the transform, and then you'll get back nothing because there's no return. So let's add a return of, so let's do this. Let's return it as a list because we got to convert it from that API object. So we'll do it like this. minPoint.x. So we'll do it just like the format that you get back when you use the Maya command as opposed to the API. And the Maya command gives you back min, 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 max, max, max. So we'll do it that way. So it'll be min okay, and then max, max, max. Okay, so that's max, max, max. Okay, so you get back a list that's got bounding box, mins, and maxes. That's the same format as you would have got above. Okay, and then we're also just printing out to look at it. Alright, so that is going to give you one more time. OOBB object-oriented bounding box. It's not aligned with the axis of the software, it's aligned with the object. It's going to give it to you in object space. So what does that mean in object space? It means when you get the max and min, they're going to be basically measured from the center of the object. So you're going to get like a plus and minus for the max and min based on the center of the object. Alright, and what that means is it's invariant to where it's positioned in space. If you move this around, you're not going to get any changes in those values because it's relative to the transform which you are moving. So that's the object space and object-oriented bounding box.